let's get some practice with solving linear equations. So over on the left-hand side here, I have some steps that we can follow, and then an example on this right-hand side, so we can kind of see how these steps apply. So the first thing that we want to do is simplify both sides of the equation. And if there are fractions, we would simplify first. It kind of depends on which stage we do this, before simplifying or after, but we'd want to eliminate any fractions by multiplying every term by the least common denominator. In this example, we don't have any fractions, but we'll see this come up in an example down below. So simplifying both sides of the equation. So what I'm going to do is distribute that 7, and I'm going to distribute this negative, it's technically a -1 right there. So distributing the positive 7, I'll have 4 plus 7 times x, and then a positive 7 times -3 would be a -21. And then equals, and on the right hand side, I'm going to distribute that -1 into the parentheses. So we'll have -17, and then a -1 times positive 6, which would be a -6, and then a -1 times -4x, which is plus 4x. And I still have another step for simplifying, and then I'm going to combine like terms, so that 4 minus 21, so I'll leave me with 7x, and then a -17, and then equals, and on the right hand side I have these like terms of -17 minus 6, so over there is going to be this 4x minus 23. So that's our first step. Just completely simplify both sides of the equation before we start moving things around. In our second step, we're going to collect all variable terms to one side of the equation, and we're going to use addition or subtraction to do this. So what this means is I have two options. I can either use addition subtraction to move 7x over to this right hand side, or I could use addition subtraction to move 4x to the left hand side. And it doesn't matter. You'll get to the same answer in the end. Something we do often suggest is moving the smaller of the two numbers. This can help you typically avoid negative numbers, and negatives just tend to give a little more opportunity to make errors, so we want to avoid that. So I'm going to move the smaller of the two, which is 4x. So what I'm going to do is, because I have positive 4x, I want to subtract 4x to make 0. And whatever we do to one side, we have to do to the other. So with that on the left-hand side of the equation, I now have 3x coming from that 7x minus 4x, and minus 17 equals the 4x and -4x turns into a 0, and we have our -23. So now we have our variable just on one side of the equation. It's not showing up on the other side anymore. Our next step is collect all constant terms. So the constants are just the numbers that don't have the variable attached to them. So we're going to move those to the other side of the equation. So where I group my variable on the left-hand side, I have this minus 17 here, and I want to move that to the right-hand side to get it away from the variable. So because of -17, I'm going to add 17 to both sides. So with that, on the left-hand side of the equation, now I'll just have 3x. And then equals -23 plus 17 should be a -6. And now we have our variable term on one side, constant term on the other. Now what we want to do is create a numerical coefficient. So numerical coefficient's the number multiplying with our variable, and we want to make that a +1. So right now I have a numerical coefficient of 3, but I want to change that to a 1. So to do that, this is typically going to come through as division. Sometimes it could come through as multiplication, but often we're dividing away the number that we see. So I want to divide by 3, because then the 3 divided by 3 will give me that +1. And whatever we do to one side, we have to do to the other. So we'll have x equals -2. Now with solving equations, always remember you can check the solution, which is really nice so that you know with 100% certainty you got it right. So what we would do is take that -2, plug it into the left-hand side of the equation, see what number we get out, plug it into the right-hand side of the equation, and you should get the same exact number out. So you should have something that balances. All right, let's look at these two examples here. So going through those steps, first thing I'm going to do is simplify. So I'm going to distribute the 9n on the left-hand side of the equation. So that would look like 1 plus 9m minus 45. Multiplying 9 with each of those pieces. Equals, and on the right-hand side I have this negative 53. And then I have this negative, again, if it helps, you can think of that as negative 1. We want to distribute the negative 1 into the parentheses. So that negative 53 doesn't change. We have a negative 1 times 1 for negative 1, negative 1 times negative 4m for a positive 4m. Then I'm just going to combine like terms. So I have 1 plus the negative 45, so that'll be a negative 44. And then negative 53 minus 1, so negative 54 plus 4m. So now I simplified both sides of the equation. Now I'm going to move my variable term to one side. So I'm going to move the 4m since it's smaller than 9m. So I'm going to subtract 4m from both sides. So that'll leave me with 5m minus 44 equals negative 54. Then I'm going to move my constant term so I get my variable term all alone. So I'm going to add 44 to both sides. So that'll leave me with 5m equals negative 10. Then we'll create our numerical coefficient of positive 1 by dividing away that number. So we're going to divide both sides by 5, so we'll have m equals negative 2. And then we could check our answer by plugging it in. Alright, this example here deals with our fractions. So that first step, there isn't anything to simplify, but we can take the step to get rid of the denominators. And what we're going to do is use the least common denominator. So basically, what is the smallest value that all three of these numbers multiply up to? So what you can do is, I don't know, it's never a quick process, but what you could do is take the larger of the numbers and start listing multiples. So like 4, 8, 12, 16, 20, 24, so on and so forth. And what I would do is then, well, all of these are divisible by 2, so I don't need to worry too much about that. But I need to worry about it being divisible by 3. So 4 doesn't work, 8 doesn't work, but 12 works. 12 is divisible by 3, 2, and 4. So that's going to be my least common denominator that we're going to use. So that step says, if there are fractions, multiply every term by the least common denominator. So what that's going to look like is I'm going to take that 12, and it's going to multiply with that 3/4 x, and then I'll have plus 12 times the 1/2 equals 12 times negative 11/3. So with that, we've multiplied absolutely every term by the least common denominator. Now when we do that, we get these cancellations coming through because we chose a number that's divisible by each of those denominators. So with that denominator of 4, what we do is we get this division, so 12 divided by 4, so we'd be left with a 3 there. So really I have a 3 times 3 times x, and I don't have a denominator anymore, which is exactly what we want. 12 times a half, we could probably simplify that completely, but that will leave us with a 6. 12 divided by 3 will leave us with a 4. So simplifying this, that first term, 3 times x, so that'll be a 9x, plus, all we have left there is a 6, and then equals 4 times negative 11, so a negative 44. So now we have something linear to solve that doesn't have fractions involved, which we know how to do that well. So this allows us to avoid math with fractions if we choose to. So solving for x, X is all alone on one side of the equation, but I need to get rid of my constant term, so I'm going to subtract 6 from both sides. So we'll have 9x equals negative 50. Then we just need that numerical coefficient of 1, so I'm going to divide both sides by 9. And that will give us x equals negative 50 over 9. Let's look at Desmos for checking the answer here, especially with a fraction like this. Like getting a fraction kind of messy like this. First of all, I question whether or not I've simplified it correctly, like whether or not it's completely reduced down. So I'll show you how to check that. But then also like plugging it in and then doing all sorts of fraction math. Just how can we have a calculator help us out with this? So let's go over to that Desmos calculator. So if I wasn't sure about negative 50 over 9 being completely simplified, what you can do is just type in your fraction, and then it'll give you the decimal out, but there's this convert to fraction button over here, and it will always show you the completely reduced form. So what I can see from this is since it's the same, I wouldn't have been able to simplify it any further. So negative 50/9 would be the final answer there. Now checking the answer, what I'm going to do is type it in, so 3/4, and then times, and then where I have x, I'm going to plug in the negative 50 over 9, and then we're going to do plus 1/2. And I'm getting this decimal out, and it should be equal to negative 11/3, which what we could do is type in negative 11/3 and compare the decimals, or again, this handy dandy convert to fraction button, which will show you it simplifies to negative 11/3. So that balances out, so we've checked our answer, and even though it's kind of messy, we know that it's right. So that's just solving our linear equations.